Hi class. In this video, we're going to be talking about some circle geometry properties. So the first property we're going to go over is the central angle and inscribed angle property. So there's a big verbiage here, but basically what it means is, let's say we talk about the central angle first. Here where we see POQ, notice this is the center of the circle right here. And this red line would be my radius, right? Because it's going from the center of the circle to the edge. And then this red line here would also be my radius. Okay, great. And now you want to look at, let's draw a blue line here. This other triangle, PRQ, this one is formed by two chords. So notice how P to R is a chord because it doesn't pass through the center. And then R to Q is also a chord. But notice one thing here. They share a common endpoint. Look at the endpoint where OP is and OQ is compared to RQ and RP. They share the common endpoint here. And when you share that common endpoint, so this common endpoint here and this common endpoint here, you also share a common arc length. What that means is whatever angle you have for your central angle, that angle will be half for your inscribed angle. So recall definition, central angle is formed by two radiuses and inscribed angle is formed by two chords. And since they share the same endpoints or arc, you can apply this property. So what that means is, let's say for example, this central angle here was, let's say it was 60 degrees. If that's true, according to this property, this inscribed angle that shares the same arc as the central angle will be exactly half of that. So then this would be 30 degrees. And vice versa. If this was 30 degrees, then the central angle has to be doubled, so it has to be 60 degrees. Okay, another property I want to talk about is that all inscribed angles that share the same arc actually have the same angle. So let's start with the triangle Q, T, and P. So if I draw a line here, Q to T, and then T to P, there is a triangle here that has this endpoint and this endpoint, right? And now let's find a different triangle. Let's use blue here. QSP would be another triangle. So, okay, that's S to Q, and now we got S to P. Okay, notice what happens here. They share a common, these two triangles share a common endpoint. And in fact, there's actually a third triangle that also shares a common endpoint. The triangle QRP. So looking here, QRP also shares a common endpoint with these other triangles, as you can see here. And when you share that common endpoint, you also share that common arc. So they all have the same arc length here, right? So what that means is if you know the angle for one of the triangles, you know the angle for all of the triangles because all of the angles will be the same because they share the same arc. So in this case here, this inscribed angle, let's say it was 35 degrees. Okay, that means this inscribed angle would also be 35 degrees, and this inscribed angle here would also be 35 degrees. They all share the same angle because they share the same arc or endpoints here. Okay, now the last one we have to talk about is, let's say I'm going to use red to show this. Notice O here is the center of the circle. From O to A, that is the radius. And from O to B, that is also the radius. So far, this is the diameter. And it has a degree of 180 because it forms a straight line. But notice that 180 is also known as my central angle. Now, let's pick a triangle here. How about we go with the triangle AHB? So for A, H, and B, let's take a look here. Notice how that triangle shares the same endpoints as my central angle. So that inscribed angle shares the same endpoint as my central angle, and hence it also has the same arc. So remember, according to that property, if my central angle is 180, that means my inscribed angle is exactly half of that. So since I have 180 degrees here, this inscribed angle that shares the same arc as my central angle must be exactly half of 180. And half of 180 is 90 degrees. Okay, let's go over some examples now. So here's an example. Point C is the center, point C is the center of the circle. Angle AEB, so AEB here, so pretty much angle E, is 35 degrees. They're asking me what is the measure of angle ADB, which is angle D. Okay, now looking at this here, we use some color. Angle AEB is what we got, right? So this here, AEB. Notice where the endpoints are. They're right here. So all of these triangles share the same endpoint and the same arc. So I can use some of my properties here. Let's focus on angle ADB. So ADB, that I'm going to use blue to represent, shares the same endpoint or arc as AEB. So that means if angle AEB here, angle E is 35, that means angle D must also be equal to 35 degrees. So that's pretty much it. My angle here would be 35 degrees. Now, it also asks, what is the measure of angle ACB? So ACB is here. So that's angle C. Notice this angle C here. Let's use green to represent that. Angle ACB also shares the same endpoints. Hence, it shares the same arc as my other inscribed angles. However, since it's formed with two radiuses, it's called the central angle. And according to my properties, the central angle must be doubled the inscribed angle if they share the same endpoints or arc. So hence angle C here must be double 35. So angle C must be 70 degrees because 35 times 2 is 70. So hence my answer here is 70 degrees. Okay, let's go over another example. Here we have point C is the center of the circle. Diameter AB equals to 10, and the chord BD here equals to 6. It asks us, what is the measure of angle ADB? So angle D here, what is the measure of that? Now, according to my property, since this is my central angle here, if you think about it, this is the radius, right? And then this is the radius. So hence that forms a diameter. I have two radiuses, that's my central angle. So this here should be 180 degrees. And I also have an inscribed angle on here. The inscribed angle would be ADB. Notice how ADB shares the same endpoints and or arc as AB or ACB. So because they share the same endpoints, hence they share the same arc all the way over here, it means my inscribed angle here is exactly half of 180. And half of 180 is 90 degrees. Okay, so what I actually formed here was a right angle triangle, if you think about it. So that means that's a right angle triangle. Across from my right angle is the longest side. That's going to be 10. And they give me one of the lengths here. So it doesn't matter which one I make it. Let's say I just let this be 6. Now I can use that logic to find out what is the length of chord AD as well. Okay, so far we answered our first question. ADB is 90 degrees. Now we have to answer our question. What's the length of chord AD? So I'm just going to look for it here. I'm just going to let this be x. So I'm going to use Pythagorean theorem. A squared plus b squared equals to c squared. In this case, I know what c squared is. So I'm going to let a squared just be x squared. I'm going to add 6 squared here, let it equal to 10 squared. So I'm going to subtract 6 squared to the other side. That gets me x squared equals to 10 squared minus 6 squared. I'm going to take the square root of both sides. So I'm just going to have x left on this side. The other side I'm going to have, so the square root of 10 squared minus 6 squared. And 10 squared minus 6 squared would be 100 minus 36. So I have the square root of 64 because 100 minus 36 is 64. And the square root of 64 is 8. Hence, x, or chord AD, must be equal to 8 centimeters.